Hello everyone, this is your host today. We're going to explore the concept of pressure creating diamonds. This is a fascinating demonstration that illustrates how intense pressure can actually form diamonds. For this demonstration, we will use a special blend that allows us to observe the diamond formation process. The instructions for this blend are provided in the description below, but essentially, it involves a few basic components that are combined and then heated into a clear liquid. Once this liquid cools, it solidifies into clear crystals that resemble tiny diamonds. A remarkable thing about these crystals is that they are composed of pure silicon dioxide, which has a composition similar to actual diamonds. To start the experiment, we'll first measure all of the required materials. 12 g of sucrose, common table sugar, 16 g of sodium chloride, salt, 4 g of citric acid, 3 g of potassium nitrate. These substances will interact to produce a new compound known as potassium silicate, which is the primary ingredient in our crystals. More significantly, potassium silicate shares a chemical composition with carbon, the key element in diamonds. By the end of the process, we aim to create stunning, transparent crystals that are chemically akin to diamonds. Next, we transfer all the ingredients into a beaker and place it on a hot plate. After adding a small quantity of water, we gently heat the mixture, constantly stirring until everything dissolves completely. The mixture is somewhat unstable, so we must continue heating and stirring to prevent it from solidifying. After a few minutes, it begins to boil, and at that stage, we turn off the heat and allow it to cool gradually. As the beaker cools, some white crystals start to appear in the solution. These aren't the crystals we want yet, as they're not clear and don't resemble diamonds. With a bit more effort, though, we can transform them into gorgeous transparent crystals. To proceed, we pour the mixture through a strainer to separate the crystals. Since they're still moist, we place them in an oven to dry. The exact temperature isn't crucial, but it's important that the oven is turned on and has adequate airflow to remove moisture and polish the crystals. While they dry, we prepare a saturated solution by taking a clean beaker and adding around 100 milliliters of hot water. We then gradually mix in the dried crystals until no more can dissolve. This results in a saturated potassium silicate solution. Now we take a clean test tube, add a few drops of the saturated solution, and place the test tube into a larger beaker filled with ice water. The purpose of the ice bath is to rapidly cool the solution, forcing it to supersaturate and become unstable. As crystallization begins, we notice needle-like crystals forming inside the test tube. This takes a few minutes, but once complete, we can remove the crystals and examine them under a microscope. Through the microscope, the crystals appear long and slender, resembling needles, a process known as needle growth. Unlike the typical cubic crystals, this form of crystallization yields elongated structures. We repeat this step several times to ensure we get a substantial quantity of crystals. Once collected, we dry them out, and under the microscope we see they are stunningly clear, resembling miniature diamonds. But are they truly diamonds? To verify, we place some crystals onto a glass slide, add a drop of water, and cover it with a cover slip. Then we place it on a hot stage and gradually heat it to about 700 degrees Celsius. If the crystals melt, they must be composed of pure carbon, like true diamonds. As we heat them, they begin to transition into a liquid, confirming that they are indeed made of carbon, just like real diamonds. Diamonds are among the hardest substances on Earth and are also incredibly beautiful. They are formed under immense heat and pressure deep within the Earth and have been revered by humans for thousands of years. Their atomic structure of carbon atoms in a specific crystal arrangement is what gives them their brilliance and durability. To replicate these conditions, we use a high-pressure reactor capable of generating up to 200 kilobars, similar to the pressure found 60 miles below the Earth's surface. We start by preparing a special mixture containing all the necessary carbon atoms, load it into a durable container, and place it inside the high-pressure chamber. We then evacuate the air and fill it with argon gas, which helps to prevent any unwanted reactions. Once sealed, we begin increasing the pressure using hydraulic pistons until we reach the target pressure. At this point, the carbon atoms begin to rearrange into a diamond lattice. After maintaining the pressure for several hours, we slowly release it and open the reactor to retrieve the diamond. It's incredibly exciting to see what we've created. Under normal circumstances, growing a diamond this large would be impossible, but thanks to our reactor, we have mimicked Earth's inner conditions and formed a real diamond right here in our lab. That's the end of today's scientific exploration. I hope you enjoyed this as much as I did. If you liked it, be sure to give it a thumbs up, subscribe, and hit the notification bell. If you're curious for more, check out my channel where I post hundreds of fun science experiments. Thanks again for watching, and I'll see you in the next video.